Now we're going to work with rational exponents. Exponents, that's that value that's raised up. Rational means fraction. So definition, if I have the nth root of a represents a real number, and n is greater than or equal to 2 is an integer, 2, 3, 4, 5, 6, on and on, then a to the 1 over n means nth root of a. Okay, so use radical notation. So we need to rewrite these in radical form and then simplify. So that means square root of 64. You do not put the 2 there because the 2 is understood. Square root of 64 is 8. This one would be the cube root of 125. Well, you can either do 125 raised to the 1/3 or cube root of 125. You should know location of that, but that should be 5. This one, notice I do not have a parentheses like I do in D. So the negative is on the outside. I'm taking the 4th root of 16, but that would be a negative, and 4th root of 16 is 2. This one, this is written as 4th root of negative 16. And what we saw earlier in an earlier video, that this is an imaginary number. Now if I did that on my calculator, pull it in here. Remember, I have to tell it if it's something other than square or cube, I have to tell it. So 4th root, let me go to math, do number 5. I'm going to type in a negative 16 and let's see what it says. I don't want to graph it. Non-real, imaginary number. So let me quit that. I can take a odd root. In this situation, I've got cube root of negative 27. So an odd root does give me a negative value. In this case, it would be negative 3. I cannot do even root of a negative number. Not right now. Another definition. If the nth root of a represents a real number and m over n is a positive rational number, where n is greater than or equal to 2, then, now check this out. It's a little bit different, but still in the way the same, because up here, now if you'll notice the m is my exponent that is either can be written to the outside or to the inside. So on this one up here, it's understood to be a 1. So technically this little definition I had up here is the same down here. So if my m was 1, then that would be 1 over n. But whatever number is in the denominator, it always is called, what's the index? It goes in the little crook of the elbow of your radical. So this one, use radical notation. So first I've got cube root of 27 squared. I'd have to use my calculator on that. But if I rewrote it as cube root of 27, that thing squared, remember I can do it either way. This would have to be done via a calculator. This one I can do it in my head. Cube root of 27 would be 3. 3 squared is 9. Let's see. So math, I have cube root. Let me put 27 squared and ask it to find it. There it is. See, 27 squared, yeah, like I know the cube root of 729. It's just easier if you have the exponent on the outside to work the problem. A 2 in the denominator automatically means square root. So let me put parentheses, square root of 9 raised to the 3rd. Square root of 9 is 3 raised to the 3rd. That would be 27. Negatives on the outsides, we're going to have to wait. This is 5th root of 32, and it's going to be raised to the 4th. negative carries. 5th root of 32 is 2. And 2 to the 4th would be 16. You can check those even with fractional form. Let me get this back over here. I'm going to type in negative 32, raise it to the 4 divided by 5. So you can check yourself on these. More than likely you're going to have to indicate work, so you're going to have to go through this, but you can check. Now on these, I'm going to rewrite each expression with rational exponents. This is understood to be a 2. That's called square root. Square is 2, so that would be 13 to the 1/2. This one would be 6. It's understood to be a 1 there, so that would be 1/3. And this one would be x to the 4/7. So that's it for this video. Thank you.